Uh, Hello, dear colleagues. Symmetry is the genetic basis of organisms and musical harmony. The genetic information in all organisms is based on DNA molecules. A genetic understanding of life itself exists. Life is a partnership between genes and mathematics. In our research, we strive to understand ancient problems. Uh, why is music an integral part of the life of people in various ethnic groups at all times? And what does the DNA base of all living organisms have to do with this? Answers to these questions can enrich not only musicology, but also give way to new biotechnologies, medical methods, artificial intelligence systems, etc. Music is closely related to mathematics. As Leibniz said, music is the arithmetic of the soul, which calculates without realizing it. In this presentation, we describe, firstly, deep connections of the molecular genetic system with Pythagorean musical scales based on the quint ratio 3/2. Secondly, the possibility of parallel algebraic modeling the structural features of DNA informatics and musical scales of the Pythagorean type using 2n dimensional double or hyperbolic numbers known in mathematics, physics, and informatics. In Europe, since the time of Pythagoras, the concept of musical harmony has been associated with the Pythagorean seven-stage scale do, re, mi, fa, sol, la, si. The sound frequencies of its notes are mutually related in a rigorous mathematical manner based on the quint ratio 3/2. In a general case, the Pythagorean scale is any scale which can be constructed from only quint ratios 3 and 2 and octaves. Examples of Pythagorean scales are pentatonic, tetratonic, and tritonic scales, all the sounds of which can be arranged in quint ratios. The known historical fact is that these Pythagorean musical scales, based on the quint ratio, were used by different civilizations around the world long before Pythagoras without knowledge of any mathematical laws. For example, the mentioned Pythagorean scales are represented in the traditional music of the Chinese, Vietnamese, Mongols, Turkish, Sound Ends, Polynesia, Melanesia, Plains Indians, the Greek Indians, the Inca Empire, and many others. This fact testifies about an inherited relation of humans with Pythagorean scales. But what is there in living organisms that determine the special attraction of Pythagorean musical scales for representatives of various civilizations and epochs? The queen principle of the formation of a musical system was borrowed by Pythagoras from ancient China. The numbers 3 and 2 were the basis of arithmetic in ancient China and were called the numbers of heaven and earth, or yang and yin numbers. Musical harmony in ancient China was considered the basis of the universe. The ancient Greeks, following the ancient Chinese, ascribed to musical harmony a key role in the structure of the world. Therefore, they attached extreme importance to the search for the quint ratio 3/2 in natural systems. Considering 3 and 2 as masculine and feminine numbers, which through their interaction generate new musical tones. Thus, Archimedes considered the discovery of the quint 3 per 2 in the ratio of volumes and areas of a cylinder and a sphere inscribed in tin to be the highest achievement of his life. Modern science has found that a pair of quint numbers 3 and 2 characterizes the structure of information sequences of genetic DNA molecules. Thus, genetic informatics is associated with a Pythagorean musical harmony. Molecules' DNA contain sequences of 4 nucleotides: adenine A, cytosine C, guanine G, thymine T. In double helix DNA, nucleotides AT and CG form complementary pairs with 2 and 3 hydrogen bonds in them respectively. From the standpoint of its sequence of 2 and 3 hydrogen bonds, each DNA molecule sees a long chain of numbers 2 and 3. The genetic code encodes sequences of 20 amino acids in proteins using 64 triplets that represent all possible combinations of these 4 letters. Under representing A and T is equal to 2, C and G is equal to 3, each triplet has a numeric representation as a product of several hydrogen bonds of its constituent letters. For example, the triplet ICT is represented by number 12. Each of 64 triplets is represented by one of such numbers of hydrogen bonds in red: 8, 12, 18, 27. The pairwise ratios between which are equal to the quint 3 per 2 in varying integer degrees. Analogy with music tetratonic scales exists here. Under considering pairs of adjacent triplets, then DNA molecule appears as a quint sequence of 7 kinds of number of hydrogen bonds with the following numeric representation in red: 64, 90, 6, etc. Pairwise ratios in this series of numbers are equal to the quint 3 per 2 in the same powers as in the Pythagoras 7-stage scale. Accordingly, each DNA molecule as a chain of hydrogen bonds is characterized by its own sequence of the quint 3 per 2 in different integer degrees. The quint ratios are realized in DNA not only for the hydrogen bonds of complementary nucleotides, but also for several other parameters, such as sums of atoms in the rings of purines and pyrimidines, numbers 9 and 6 with their ratio 3 per 2, or sums of protons in the rings of complementary nitrogen bases, numbers 60 and 40 with their ratios 3 per 2, and others. In other words, nature created DNA as a plexus of various sequences of quint ratios, a quint polyphony of DNA. The harmony of the parametric organization of the genetic system is akin to the musical harmony of the Pythagorean scales. In musical scales, the relationship between two note frequencies plays an important role, and the absolute values of individual sound frequency is not essential. This resembles the situation with two-dimensional number systems, in which one two-dimensional number is a single bundle of two real numbers. Modern science is inconceivable without the use of two-dimensional and multi-dimensional number systems, complex numbers, double numbers, dual numbers, quaternions, etc. They play the role of magic tools for theories and calculations in acoustics, thermodynamics, electromagnetism, hydrodynamics, quantum physics, communication informatics, etc. But unlike other fields of science, multidimensional numbers are not used in musicology and the theory of aesthetics. The author shows the possibility of representing systems of quint ratios and musical scales in the form of two-dimensional double or hyperbolic numbers and their algebraic extensions. Over the centuries, from ancient China to antiquity, the numbers 2 and 3 were considered respectively as yin and yang numbers, forming the important pair. The authors propose their consideration not as separate one-dimensional numbers, but as two separate parts of a single two-dimensional number. Taking into account a set of our results on relations of the genetic system and inherited physiological phenomena with double numbers, the author's choice, namely double numbers for a presentation of these historical and known numbers 3 and 2 as two interrelated parts of a single two-dimensional double numbers 3 plus 2g, where g is its imaginary unit with its known features. G in second power is plus 1. In a general case, double numbers x plus g y have a matrix form of their presentation whose tensor powers give a family of two n-dimensional double numbers. This family has an analogy with the known representation of DNA alphabets of 4 nucleotides, 16 doublets, 64 triplets, etc., in a form of the tensor family of genetic matrices, CATG and 10 tensor power. Remembering the representation C and G is equal to 3 and T is equal to 2, we get the tensor family of quint matrices 3, 2, 2, 3 in n tensor power, which model numeric ratios of note frequencies in Pythagorean musical scales. The square root of these quint matrices unexpectedly gives matrices that also represent two n-dimensional double numbers, but with components which are the famous golden section, phi, to an integer powers. This new tensor family of golden matrices, which are the substrate of quint matrices, leads to a family of microchromatic scales called, due to their mathematical properties, Fibonacci stages scales or pentagram scales. They are related to genetic informatics and to genetically inherited phyllotaxis laws linked to Fibonacci numbers and the golden section. They are also associated with the pentagram, an ancient symbol of health among the Pythagoreans. More details one can find at the website, including the following books published in Russia and USA. Conclusions. The well-known phenomenon of the prevalence of Pythagorean musical scales in different ethnic groups and eras is explained by the affinity of the genetic coding system with algebraic quint series. The natural possibility of using two n-dimensional double numbers for modeling the structural features of DNA informatics and Pythagorean musical scales in order to develop algebraic musicology and study the relationship of the genetic system with musical harmony is revealed. Thanks for your attention.